Hello everyone, welcome to our channel Code with Sunny, and in this video we will be talking about the problem called minimum remove to make valid parenthesis. Its index is 1249 and it is the medium problem of the LeetCode. Okay, you can see our number of likes over here is quite much. It means that yeah, this problem is totally like interesting. You are going to learn a lot of things over from this problem. And also before moving on, let's look out the section called related topics. You will find you are going to have the stack, that is you need to know the concepts of stack, how we are going to use the stack to find out the minimum amount of parentheses that we need to remove. That is, to solve this problem efficiently we need to know the concept of stack as well. Okay, and also I would strongly recommend you to do this problem like if you're done with this one, like this problem, then you should go over to the section similar questions. Then you will find minimum number of swaps to make the string balanced, as well as check if a parenthesis string can be valid. So first of all I would recommend to do the second one, that is this one, check if a parenthesis string can be valid. Okay, like after you're done with this one, then you should do this problem. And there is also the second problem, minimum number of swaps to make the string balanced. This one is quite tricky. Yeah, you can also try this one also, like if you're done with both of these problems, right? Okay, so let's talk about this problem, that is we are going to discuss in this video how we are going to use the stack to solve this problem efficiently. So let's begin. Given a string s that consists of this close parenthesis as well as this open parenthesis, okay, and the lowercase English characters, and our task is to remove of the minimum number of parentheses, either an open parenthesis or a closed parenthesis in any positions, so that the resulting parenthesis string is a valid and return any valid string. Okay, that is we need to remove the minimum parenthesis such that the string, that is the input string, becomes valid. And there is a definition of valid string that is also given over here. You can see a parenthesis string is a valid string if and only if it is an empty string and contains only lowercase characters, or it can be written as this format as well as it can be written as in this format. I will explain all these concepts in this video. Okay, so let's first look over the constraints also. So let's you can see the max length of string is around 10 raised to the power 5. So it means that you are going to have a O of n log n solution in worst case, or O of n solution, that would be much better. Okay, so in this video we'll be talking about O of n solution, how we are going to optimize the solution with the help of stack. So let's first understand this problem in detail. Okay, so let me just open my this editor. Okay, so you can see let me first talk about this concept of valid string. So let me just choose some color. Okay, valid string. Okay, now a string is said to be valid if every opening parenthesis, like you're going to ask, this is an open parenthesis, every opening parenthesis must have a closing parenthesis, as well as every closing parenthesis must have an opening parenthesis, vice versa, that is you're going to say vice versa. And also you can see any number of characters can be present over this position, like lowercase English characters like a b c d e, any number of characters, as well as after that also like a b c, and previous to the open parenthesis also a b c. And also you can see if we append two valid parenthesis string, that is also valid. Suppose if we have this a b, this is a valid parenthesis string, let me write down valid. When you append another valid parenthesis string, let's say cd, now this is also a valid parenthesis string, like this complete string is a valid parenthesis string. Okay, so how do we find out the minimum number of parentheses that we need to remove so that the resulting string is a parenthesis string and it is a valid string? Okay, so the concept is quite simple if you use a stack. Okay, so what stack does is like it will insert the characters to the top of the characters that we have already taken it. Okay, so let's take an example and understand how this is going to be done. So I will pick up this one. So let me write down the string s equals Lee, and followed by this opening parenthesis, then t, then we have C, then it is closed, then we have O, then closed, then we have D and E, right? And finally we have a closed parenthesis over here. Now, okay, so we would be using a stack to store the characters, right? Okay, so whenever we have a, let's say L, like whenever we have a lowercase English characters, lowercase characters, we would skip it. I will tell you why we are going to skip it. We only need to know the parenthesis that needs to be deleted, right? But yeah, that needs to be deleted. And stack is going to check it out whether this parenthesis should be deleted, should be like we should delete it or not, right? So the stack is going to store the indices of the parenthesis that is going to be deleted, right? Or like the current parenthesis is going to be, like we are working on this set of parentheses. Okay, now, okay, so let me start with the strings that is being taken over here. For the case like L, E and D, we are not going to insert any of this into the stack. Okay, now this is done. Now whenever we have an open parenthesis, you can see this one, open parenthesis, I will take its index, right? So what is the index of this one? Let me just figure it out. 3. Okay, so we'll push up the 3 into the stack. Okay, now T is going to occur, then we are going to discard it because we are not going to consider any lowercase characters. Now again we have this open parenthesis over this position and its index is 5. So we will write down, like insert this one into the stack. Note that stack operates like first in last out, like FILO methods. Okay, so last input is like index 5 and it is denoting that yes, we have a parenthesis string over here. Now again you can see we have C, I'm going to discard it. Now we have a closed parenthesis over here at the position 7. Now, if you consider the definition of the valid string, every parenthesis string, valid parenthesis string denotes that whenever we have an open parenthesis, we must have a closed parenthesis and vice versa. Like for every parenthesis, this must hold. Like whenever we are encountering a closed parenthesis, there must be an open parenthesis that must be present to the left of it. Okay, that is going to satisfy this close parenthesis, right? So now you are going to see a close parenthesis over here. So this must be satisfied with an open parenthesis. Okay, so if this is not being satisfied with an open parenthesis, we must have to delete this close parenthesis, right? You can see now we are having a close parenthesis and the latest character that is being denoted by a open parenthesis is present over here at the index 5. That is the information used by the stack. Stack is going to store the indices of open parenthesis that is still not being used. Okay, so you can see position 3 is not being used, position 5 is not going to be used still, like till now. So whenever we have a close parenthesis, we will extract out the latest, that is the maximum index up to the current position, which are having an open parenthesis. You can see the latest character is 5, present at this 5, which have an open parenthesis. So we will use this one to close this close parenthesis present over here. Okay, so what I'm going to do is I'm going to discard this 5. Okay, so my new stack becomes containing only in the index 3, that is for this open parenthesis. It means that this open parenthesis must be balanced with this closed parenthesis. Okay, now again this O character skipped. Now we have a closed parenthesis, right? When we have this closed parenthesis, you can see this must be satisfied with an open parenthesis, right? So what we are going to do is we are going to extract the latest parenthesis. What is that latest parenthesis? Which is an open. Okay, so latest parenthesis which is open is present at this index 3. So we will use this close parenthesis, like we will append, we will pair this close parenthesis with this open parenthesis. So 3 is also going to be discarded. So my new stack is empty. Okay, so you can see the index 3 is being paired with 9, that is open parenthesis over this one and close parenthesis over this one, and index 5 is paired with 7, open parenthesis is, at this position, close at this one. Now we have the character called, you can see, let me just change the color. We have the character D and we have the character E. We are going to skip it. Now we have a close parenthesis over here. Okay. Now, whenever we have a close parenthesis over here, we are going to check the entries in the stack if it has some open parenthesis, latest open parenthesis having the maximum index to the left of it, which is still not used. You can see the stack is empty. It means that this character must be deleted. Must be deleted. So we are going to delete this character. Okay. So this is the entire concept. Now suppose that after all the operations being done and stack is non-empty. Like after all the operations has been done. In this case, you can see stack becomes empty. Like suppose there exists some input string where the stack is non-empty. In that case, we have some open parenthesis, right? So we need to delete that open parenthesis because there doesn't exist any close parenthesis that is going to satisfy these open parentheses, right? So we need to delete that also. Okay, this is all about this problem. So what we are going to do is we are going to implement all these concepts over here. So you can see, let me just open up my submissions and let us move over this first submission which is accepted. Okay, so what I'm going to do is like we have this n as strings length, and yes, we're also going to maintain a boolean vector that is going to mark whether this character should be taken or not. Like if taken of I is true, it means that this character is not deleted, and if taken of I is false, it means that this character is going to be deleted. Now we have a stack of indices that is going to store the indices of open parenthesis, and that is going to help us in determining whether we are going to delete the particular character or not. Okay, that is whenever we encounter a close parenthesis, then we will check the latest entry, that is the maximum index present to the left of the current index, that is going to satisfy this close parenthesis, right? Okay, now you can see we are going to iterate for the n times, and whenever we have an open parenthesis, we are going to push up its index in this stack. Okay, and whenever we have a close parenthesis, we are going to check it out if the index, like the stack, is not non-empty, then we will extract the latest index that is going to satisfy this close parenthesis, that is an open parenthesis is going to pair up with this current close parenthesis, right? And if stack is empty, you need to delete that close parenthesis. So I will say take of I is false. It means that this should not be taken, this character should not be taken in the answer. Now as I've already said, after all the operations, the stack may that is stack may be non-empty, right? So we need to delete all those open parentheses. So I will mark all those indexes as false. Now we need to write down the answers, take answer vector and iterate over this entire string, and if take of I, that is true, it means that we need to take that index, take that character. So we'll push back that character to our answer and finally return the answer. This will give you all test cases passed. So if you guys have still any doubts, you can reach out to us through the comment section of the video, and thank you for watching this video.